everyone. Good evening to you all. We are back in our software engineering course, and today's topic is software project planning. So today we will cover topics on project planning. Let me put it on slideshow. Yeah, that's better. So we will deal with some of the topics in software project planning. We'll discuss some of the basics, and then we will look into the project planning activities. What is the sequence we will follow it? We will look into the output that comes out of the planning, which is called as the SPMP. And we will also look into the project estimations. Under the project planning, there are many activities. So we will look into the project estimation. We will look into project team organization, and we'll look into project metrics. And under project metrics and process metrics, two types of metrics, under it we will discuss some of these topics. And we will try to make it more on the interactive mode, and we will be you can put your questions, and I will try to put it in question method. You can put in your doubts, and I will put everything in a question method, so that it is easier for you to answer your exams or in your interview. And we'll try to do some problems also. So let's start. So the first thing that will come to our mind is, what characteristics differentiate a software project from engineering projects? Why are we dealing software project management separately? Is it not same as other project management? What makes software project planning and management difficult? So this is one of the questions that is normally comes in the exams. So when you write, you can write about these four characteristics. That is visibility, conformity, ability to change, and the complexity, which is connected, and also the return on investment, ROI. So why visibility? Why we think visibility is the major concern? Because as you know, software is not visible till it is complete and delivered. Only when it is given to the user as a complete form, complete development, then only there is some visibility to it. People can interact with the software. But till that time, the user cannot know it. So it's an abstract nature. And the progress cannot be seen by the customer. That's why they feel difficult. They don't know how much has been complete. So the project management planning has to be done in such a way that we can show something to them. Then there is a conformity. What is conformity? That's a specification that is given to the software team is from the user's mind, their perception. So, and also whenever it is human perception, it will have conflicts and also variations. But this is not so in other projects. In most of the engineering projects, the specification of the product will be derived by using some scientific theory or an analytical method. So there will be a single solution to it. There will be a single specification and there will be a single solution to it. So it is much easier to comply when the things are so concrete. It is not like that in the case of software. Next is the ability to change. Ability to change means any time you can get changes in the software product till you are delivered it. After delivery, changes will come in the maintenance. But in most of the engineering projects, people will discuss till the design. Once the design is done, specification is created and the design is made, then nobody will bother about any change, because it has to be manufactured as per the design. So the tools and dies and that machine has to be put in the same fashion. So once the design is done, then the production starts. So there is no more change you can do. It's not like that in here. So we have to manage the change till we are doing the delivery. So that is one of the most difficult challenge in a software project. And the complexity is very high because we need different engineering skills, software engineering skills of different type we will need, and every project is of a different type and skills are changing, they are emerging. Technology is always changing in software, and it's that is why it is very complex. Whereas in the most of the engineering projects, technology changes, but it doesn't change at that pace as in software. So people use standard materials, standard. There are a lot of standards which they use, and the skill set is also standardized over years. So there is not much of complexity. Anybody can do it. I mean, if you can get the skill set, then you can do it. But here we have to develop the skill set. We have to develop the technology. So it's very complex. And a return of investment also cannot be accrued. That means you cannot divide the software in such a way that part of it, when it is done, it can be used and some income can come, return on investment. So whatever you have invested, some return can come. But in engineering projects, they can do it by stages. They can do it by stages so that they will get a faster ROI. So you can write these four things. Now we'll go to the next one. How many types of stakeholders influence the software project? As you know, we have discussed about stakeholders in our other classes. Something wrong here. 1 minute. Okay, we'll see. For some reason, I am not able to see the chart. Okay, I think it has come. So external stakeholders are there, internal stakeholders are there, and there are some stakeholders who are internal to the organization but external to the project team. So basically, there are three types of stakeholders. And how do we describe these stakeholders? In external stakeholders, you have senior managers, business managers, who have significant influence because they are the ones who define the business issues. And they also have an influence on the project decisions regarding scope, timeline, budget, quality. These are very important parameters for the software project. And any management activity, they have an influence. Then the customers who specify the requirements that will be engineered. So basically, they tell you what product they need, their requirements they will tell. And the end users are mostly operational staff who will interact with the software and do day-to-day business. Many times this customer and the end-to-day business is sometimes same person. Sometimes these are senior people and these are the down the line operational staff who will actually execute it. And these are like leaders or managers or business analysts. So then you have the internal stakeholders who are the practitioners. That is nothing but the technical team members. Like all of you will go and join the software engineering firms. So you will become part of a technical team. So you will become practitioners because you are practicing software engineering. And then you will have technical managers. You will have a manager or a project lead in your projects, and they will be doing most of the planning, and they will be motivating, organizing, so communication, controlling. So these kind of things they will do. And then you have some other type of stakeholders which are internal to the organization. That means they are internal to the organization which is doing the project, but external to the project team. They are not part of the project team as well. So who are they? They are support staff. Either they could be support staff from the people who are doing the project, or they could be support staff from the customer side. Some of the vendors who are giving us tools or giving us training, then some management staff who help us in the carrying out the project. Now, why do project fail? What will go wrong in planning and managing the software project. So there could be several reasons. If you are asked such a question, and sometimes you are asked, give five reasons, five major reasons. So what I have done, I have written down many of these so that you are easy for you to understand. The first part deals with the requirement and the customer's scope of the this one. So as you can see, software team members don't understand their customers' need because they are technical team members and they are business people. So there is a difficulty in understanding. The scope is poorly defined. That means there is no clear boundary of the scope. So sometimes something which is outside also becomes part of the scope. So there is something hazy here. We don't know whether this is part of the project or it is part of the business. And it can be ambiguous. That means, again, clarity is not there. Here, clarity on the boundary. Here, clarity on the requirement itself. It could be incomplete. It could be ill-defined, not well-defined. So ill-defined is the opposite of well-defined. And business needs will frequently change. So changes are not managed. So when you don't have a proper management of the change, that's why I said this is the biggest challenge in the one of the biggest challenge in a software project. So that could be one of the major reasons for the failure. So requirement related and change related things. Then we come to the effort and the timeline. So here you have underestimated the effort. You have not done a proper effort estimation, because estimation is another part of the project planning. So unless you are able to do that properly, then you have a problem. And deadlines of the project completion are unrealistic. Why it is unrealistic? Because customer has imposed some deadline, some timeline for the project, and the team is unable to deliver it. So then there's the project failure. There could be a lot of risks, and risks can be of two types: predictable and unpredictable. Predictable risks are those that are known risks. So one person can be prepared for it. In the project planning, you can plan for the predictable risks, but there will also be unpredictable risks for which you cannot plan. Sometimes users are resistant, they don't cooperate, and also there will be a lot of miscommunication. Either there will be miscommunication among the project staff itself or with the customer people. Then you come to sponsorship. Sponsorship are people who provide the funding, sponsors. They are another type of stakeholders. So either the sponsorship will be lost halfway or it is never given. So if it is not properly obtained, the sponsorship for the who will fund the project, then halfway it may get winded up. Then technical difficulties may come, which were not known in the beginning. Because why it is not known? Either it is a new technology or the project team lacks enough people who have the appropriate skills in the technical field or the environment in which you are working. The technology that we have chosen for implementation, sometimes it changes. Its version change, its features change. The older version which you have started is not supported, so you have to port it again, change lots of things. So a lot of technical difficulties may come, technology related, and because of people not being able to tackle those technical difficulties because they have less skills. Then there is some managerial or practitioners problems, because people tend to do things as per their own way, and there's many times forget to use best practices. And if there are some mistakes that has been done in the previous projects, there is something called as a lessons learned. Those tools are not applied to every project. So if you don't use the best practices and if you don't take care of errors, wrong thing that you have done, so you don't take care of the lessons learned and the best practices, then automatically you might be doing some wrong practice. In that case, obviously, the project will fail. So you can be asked about the categories or you can be asked about the actual ones. So accordingly, you can answer. Now there is something called as W5HH. So now many times the question comes, what is W5HH? What is its use? What is that approach to software project planning and management? So this is the kind of the question that will be asked. And this approach is given by our software engineering guru Bohem, and it addresses 5 things: objectives, schedules, scheduled and milestones. That means when what will be over, responsibilities, who will take what responsibility, management and technical approach, and required resources. And all these 5 things are it can be addressed by using 7 category of questions, and the 7 categories are basically what I have listed here. As you can see, there are 1 2 3 4 5 W's. That's why it is W5, and H and H. So it is very easy to remember the way Bohem has put it. So you have to go for all the W's: why, what, when, who, and where. And then you have to go to the how, to hows. So whenever you are asked of W5HH, remember this: why, what, when, who, and where. So why the system is being developed? Find out the right reasons for it, valid reason, correct reason. What will be done? What exactly is the requirement? What kind of task will have to be done to get the product? So here you have to elaborate. You have to get the requirements, elaborate it, do your models. When it will be done? So get the best project schedule. So you have to know when what is to be delivered, when what is to be done, which task to be done, what milestone will be achieved when. So those when things will have to be addressed. Then all the who things will have to be addressed is the next category of questions. Who is responsible for a function, any task, or any kind of responsibility. So all the roles and responsibility has to be defined for each member of the project team, as well as from the customer side. Anybody who is concerned with the project. Then we come to where. Where are they organizationally located? That means how the team is located, which place they are. So if there are some externally located stakeholders, if they are not near the project team, then we have to find out what responsibility they will do and how they will, what is the mode of working with them, how they will communicate. So this where is a very important thing. So we have completed why, what, when, who, and where. Now we go to how. So we have to ask questions on how the job will be done technically and managerially. So what will be the managerial process? What will be the technical process? That strategies and processes have to be defined. And how much of each resource is needed. So when we develop, so we have to develop a proper type of estimation. Not only that, we have to develop the estimation of the effort, how much work will have to be done, but we have to also express it in terms of resource type. What type of resource will be required? So this effort has to be translated into resource type. Yes, sorry. So this is what resource type. For each task and work product. For each of the task and the work product, we have to tell how many resources will be required and what type of resources are required. So then this how part will be answered. Next comes to the next question, that is the software. What are the software project planning activities? What kind of activities are done? So let's go to the goal first. Our goal is to establish a pragmatic strategy. That means a working strategy, a workable, realistic strategy for planning, controlling, tracking, and monitoring. So the way we will do our plan in such a way that we will able to do control, we will able to do tracking, and we will also monitor the project properly. Basically, tracking and monitoring are similar. Then what is the major activity? The major activity is to estimate effort, cost, and provide a detailed schedule. This detailed schedule will become the roadmap. This is what people will do. When what will be done, what task will be done, when what delivery will be given. And along with this major planning, major activity, we will also do lots more of other planning activities. These are the develop plans and strategies for resourcing. What kind of resources will be required, when they will be required, how many of those resources will be required, not only human resources, but also your computing resources. Then you have to bother about the team organization, how the team will be organized, what is the method. So we'll look into some of these. Project monitoring and control, how will you do it? What is your strategy to do project monitoring and control? How will you, we have to plan for the quality assurance and the metrics. So you have to plan for all these things. Then you have to analyze some of the risks and you have to plan how you will tackle your risks. So risk management is another plan. Similarly, configuration, because software will keep on changing, so many work products will be created. So how to keep the configuration of that? This is mainly important because we have to deal with the change management. And then we have to see how to do the validation and verification. That means how we will check that the product is as per the requirement or as per the specification, and how we will do the delivery, and how the customer will give its acceptance, or if the customer does not accept, then what will be the action from the point of the team, how it will be. If there is some work product which is faulty, then how it will be taken. So all these plans, all the strategies has to be developed as part of the project planning activity. So there is a one major activity and there are so many secondary activities. Now, since we are making so many plans, so now the next question that will come is, what is the output of the planning? And if it, and what are these contents? What are little content? Just like our design, we saw that there are so many models, or there are so many module charts and things like that. Similarly, when you do the planning activity, such a lot of activities, what is its output? So the output of the planning is known by the name Software Project Management Plan. In short, SPMP. It's a written document which is reviewed by the quality assurance people, and it is published to all stakeholders. I mean, all stakeholders are knowing what is being planned. What is the kind of contents it will have? It will have the project title, description, which will have the objective, scope, major functions, that it will scope and the major function of the product. Performance requirement, how it will perform, either the speed or the database or all the non-functional requirements. Then any management or technical challenges that may be faced, or if there is any constraint that the project will face. So this is related to risks. Constraints are mostly related to risks. They might fall into the risk category. Similarly, project estimates, basis of estimation, how you have estimated, whatever you have estimated, what is the basis. Any past historical data that you have used. And what you will estimate the effort, you will estimate the staff, that is requirement, resource requirement, and also the cost and the duration. That is the schedule. After doing the duration, you will make the schedule. Normally, many people think that the project schedule is the major plan. It's not really that. You have so many things. So you will do the schedule. So you will do the activity decomposition. You know how much duration you will take. So you will create a schedule chart or an activity network. So there are many ways you can present the project schedule. Either you can present it in a tabular form or as a schedule chart, like a Gantt chart or a bar chart. It will have timeline on one side. In this side you will have time, and here you will have all the activities. Or you can create an activity networks. We will deal with it in a something. This is called a project network. Like project networks, you have read networks in your other classes. So like that, you will have activities here. So project schedule we will have to prepare and present it in one of the methods. Then we have to know the resourcing, because we have done the cost. So resources, when it will be required, it is hardware, software, staffing, special resources, any external resources. And project organization, we have to do the team structuring, report structuring. That also will be part of our SPMP. The project monitoring control plan, quality assurance plan, risk management plan, and many miscellaneous plans. Miscellaneous plans could be how have we tailored the process, what is the process we will follow, what is the configuration management plan, testing, verification, validation, plan for delivery acceptance, and the maintenance plan. So all this planning, whatever we have done in the previous slide, the output of that in a written document form will be part of a SPMP. So SPMP is a very important document, just like the design documents. So also SPMP is a very important document in projects. If you are the project manager, what steps will you follow in the project planning process? So if this is your question, so you have to put yourself in the project manager's shoes and answer this. Basically, you have to answer what is the project planning process. So these are all the activities that you will do. So we have seen the activities, we have seen what is the output. Now we are trying to see what will be the steps. If you go to the project planning process, what will be the steps? So major steps in the project process will be, first we have to do the scope. Then we have to do the feasibility, whether the scope we can do it or not, whether it is feasible or not. Within the constraints, because we will have some constraints of timeline and also fund. So there will be a money. I think we have discussed in one of the classes some of these methods, or maybe we will be discussing it. I think I have already discussed feasibility. Different type of feasibility we discussed. Money and time is the main, and also we will also look at the technical. So any technical problem is there that we will check. Then we will analyze the risks or the constraints. Again, we will go to some of the known risks, and we will have to break our head to find out if there are any unpredictable risks. And we will have to find out how to take care of these risks. So we will do some risk planning. Then because of the risks, how it will affect the scope, how it will affect this effort, the cost, everything. So then we will make an estimate of the size and the effort, and also the required resources. Then we will develop the project schedule, and finally we will derive at the cost of the project. Then we will do all other kind of planning, that is resourcing, organization, project monitoring, control, configuration, quality assurance, etc., etc. So then it comes to our mind that somebody can ask, instead of asking what are the steps, they can ask you, illustrate by sequencing. Can you create it? Can you create a sequence of activities? Instead of saying it in 1, 2, 3, 4 form, can you say it? So I have just drawn a graphical form. What are the tasks? You start with the project scope, and go to the project feasibility, come to the size, effort estimation. Then you branch out. One, you come to the activity identification. You do the activity duration estimation. From activity identification, you can go to the activity sequencing, and you can create the activity schedule. And in the other way, you can do the resource estimation, what kind of resources will be required, and the activity duration estimation. And these two things you can put together and determine the project staffing. Once you have got the project staffing, you can determine the cost. So as you can see, the size was our first, then we went to effort, and then we went to all these things. And once this staffing, cost, and schedule is established, then from the identification of the activity and the effort and the size and the scope, we can come to our other plans. So what is the basis of estimation of a project? So now we have understood that estimation is one of the major activities, first activity, one of the first activities in the project planning. So the question will be, what is the basis of estimation of a project? What general approach can be used? So as we saw, we always did the size first. So size of the product or any activity is the basis. So this is like the independent variable. In mathematics, we always talk of independent variables and dependent variables. So if you write y is a fx, if you write y is equal to fx, x is your independent variable and y is your dependent variable. So similarly, in the question, when you come to your software estimation, your size is your independent variable. It is the main basis. So first you have to establish your size, and then you can go for the other estimates. Okay, so either you have to do the full product, or you have to determine activity by activity. You have to determine the size and then sum up all those things and get the complete product. The first step for estimation is to understand the scope of the software, generate the estimate of the size in terms of two things. So you need a unit. Whenever you measure something, you need a unit. So if x is your independent variable, you need to know how you will express x. Okay, so if size is your independent variable, you can either write it as LOC. What is LOC? Lines of code. And what is FP? It is function point. So this is a count of the functions that is available in the scope or the requirements. And this is an estimate of how many lines of code you will have to produce when you develop this software. When you convert the requirement into software, how much lines of code it will take. So that is the estimate we have to do. So the software size is always expressed either in terms of LOC or FP. These are the units in which you will estimate your size. To make an accurate size estimation, so if this is not accurate, because this is the independent variable, if this is not accurate, this is the main basis, all other estimates that you do based on this size will become wrong. So that is why it is important to have a very accurate size estimation. And this estimation, how you can do it accurate, you can decompose the large complex software to smaller units. We have done this partitioning in the designing also. The similar way we have to do. If we have already got it, it's very good. Otherwise, if it is not done in the way that we can plan, then we will again use something known as the work breakdown structure or WBS technique. So here we are not talking of the product breakdown, we are talking of the task breakdown, because we are talking of the work that we have to produce, the work that we have to do or the work that we have to produce. So that task level we have to go, so that each task we can estimate. So decomposition can be problem or process based on a combination of the both forms. So you can either do it problem based or process based. In the process based, you will get task. You do problem based, or it can be a combination of these two. It can be a hybrid form of partitioning. If you do a problem, then you will get features, or you can get components. And size will be translated to effort, time, and cost. How we will do it? We need some formulas for doing it, or we need some other things. So there are different ways. One of the reliable, either we have to get some reliable metrics of past projects. So we can look into the past projects, which is normally kept in the project database of the organization which is doing the projects. So we have to look into a similar project and get some metrics and compare it, and based on that we have to estimate it. Otherwise, we have to go to some empirical methods. Why I call it empirical? Because most of the algorithmic or parametric methods are in software engineering for estimation are derived by doing lot of observations or experiments. That is where they are. So they can be either parametric or algorithmic, and they are derived by doing lot of experiments. So they are empirical methods. Other influencing factors. Once we have done this, then we can look into other influencing factors. There could be some other factors which are not directly. So one thing is you will have y is equal to fx. And then you can have something more also, some a plus or a to the power something like that. So that can be another term that also affects your estimation. This can be estimation of effort, time, or cost, or resources. So that those could be many factors like software team ability, characteristics of the requirement, development environment. So these kind of efforts, depending on the estimation methods will derive all this, and based on this, you will have to factor this. You have to take the effect of this into your estimation. So that is the general approach to the estimation. So what we have defined the basis. That's why I put it in blue. And this part is your basis, this whole part. This part is your basis and this part is your approach. Now we come to the estimation method. So your question can be, what are the different estimation methods? So as I told you, algorithmic is one of the methods. That means you are using some effort drivers representing the characteristics of the target system and the implementation environment to predict the effort. So there is an algorithm which you have written, which takes care of both the size as well as some of the other drivers, which can depend on influencing factors, environment to predict the effort. Then you could have an analogous method. Analogous method means you are looking at the past project to find some similar one, and you are trying to find out what is the difference or the distance between the parameters of the past project and the current project, and based on those metrics you are determining the current project estimation. Then you can go for expert judgment. That means you are taking the advice of experienced people and they will make an estimation, and you try to combine them in some way, and there is a Delphi technique. So Delphi technique comes in expert judgment method. Then Parkinson's is not exactly a estimation, where some staff are available, so you have to fit your project scope into the available resources. So here actually estimate is there. We are mapping the scope into the effort that is available, estimate that is available. So it is not good for development project, but it can be applied for maintenance. Then you have price to win. That means you are not really bothered about the realistic estimate, but you want to win the project. There is a competition, there are multiple bidders. So what you do, you try to get a low value so that you can win the project. So that then becomes your estimate. So you have estimated something, and then you find that X1 is, if you quote X, you will not get the project, but if you can quote something low in X1 which is lower than X, then you can win it. So it is called price to win. Then bottom up approach. These are the two mostly used. Bottom up approach, software is decomposed using WBS, which we have recently discussed. Then using a procedural approach, size of each smaller part of the software in LOC is determined. So you use a procedural. Why we call it procedural? Because we are using line of code. How many lines of code? So it's a procedural approach. Procedural code, you try to express it in procedural code. This is converted to effort and cost using some past project data. Again, you use the past project metrics. Some productivity metrics you use. Then you go to top-down approach. So here you are doing all the lower levels first, and then you are summing it up. You are climbing the tree up. That is why it is a bottom-up approach. If you have a top-down approach, that means you have the software on the top. So you are determining here, the top of that is the complete software. And once you have the estimate, then you are distributing it into smaller components, E1, E2, E3, like that. If you have 20 components, then you will have 20 such estimates, which will be E divided into so many. So here you are summing up, you are doing bottom and summing up. Here you are doing at the top and you are distributing it. So the estimate of the project as a whole is determined from the problem statement using a parametric method. Again, a parametric method will be used, or an algorithmic approach. And if you go, well, we will be looking into COCOMO in another class. So today we will try to see whether we can cover FP. So these are the two major, this is function point and this is COCOMO. So these two are main methods in which where top-down approach is applied. That means we get the estimate of the project as a whole by using some parametric method. So let's look at some of the problems. Let's say a development team has decomposed the target product into 5 modules, P1 to P5. So they have used already the WBS. They have used the WBS and they have got 5 modules. These are at the leaf of the tree. And they are now using expert judgment for determining software size. So first initially we will look at the software size, and for determining the size they are going to experts. So what the expert does, the expert provides a minimum guess, a best guess or most likely guess and a maximum. So for each component P1 to P5 he gives 3 estimates. So this is P1, 26 is the minimum, this is the most likely, this is the best, or this is the worst, maximum size. This is the worst case, this is the best case and this is the average, most likely. Probably, most likely, this is what will happen. This many person days will be required to complete the P1 component. Similarly, P2, P3, P4, P5. And what is this? These are all in terms of KLOC. What is KLOC? 1000 lines of code. So we have to determine the how we will do the, we have to determine the estimated size of the complete software. So what we do, we use this kind of statistical formula to use the to get the expected size or the average size. So what is the average size or the mean of this? The mean of this is for each component maximum size 4 into multiplied by most likely plus minimum size divided by 6. We normalize it by 6. So we will calculate this. So you take the first one, 26 is the lowest minimum size, and this is the maximum size, and this is the most likely, which we weight it by 4, and then we add this and we divide it by 6. So you get 29.33 K LOC. Similarly, we do P2, P3, P4, P5. Then what we have to do, because this is WBS bottom-up approach, so we have to add them. We have to sum the size of the modules P1 to P5. So if you add all this, you will get your answer something like this, 167.49 K LOC, 1000 lines of code. And either you can round it to 167, or in fact you can also round it to something higher, 168 or 170 KLOC. Okay. So I think this is a very simple problem which all of you can attempt. Now we come to a slightly different problem. Here a company uses sales agents for selling healthcare products. So here we are being given a scenario, a business scenario, and we are asked to determine the complexity, the size and complexity of the software, so that an estimate of cost and time can be done. So what is the scenario? A company uses sales agents for selling healthcare products, and how they do the business is that the agents will get orders from customers over phone, just like your people come home and sell products, or the insurance people come and do it, they are agents. And they intimate to the central store. Once they have got the order over phone, they will intimate to the store to ship the goods. Then they will collect the payments as per bills. So bills will be raised and payment has to be collected by the agent. The central store has to maintain enough stock for different items so that it can cater to the sales, whereas and when the agents require, they can ship it. So they have to match the demand of the agents and maintain the stock. Now what happens? They want to scale up and they want to grow the business into different areas, different zones. So then the company wants to use a software, because this over the phone and manual maintaining is very difficult. So they want you to develop a software for it. But they are business people, they don't know anything. So they are telling that you please first you tell me what is the size and complexity, how much, then you give me an idea about the cost and time. So today we will not go to the estimate of cost and time. Today we will first look at the basis, because now we are at the basis, the size. So what, as a team member, what you will do, or as a project manager, what you will do, you will use the FP method, because here you are told about the functions that the software will do. It is very difficult for you to make it into, you don't have experts, so you cannot go into the, you have not done the work breakdown, you have not done enough work to do the work breakdown, there is no clarity. So, but some amount of idea is there about the functions and the features. So you do the top-down approach. So you use the FP. Instead of COCOMO, you use the function point. Now for the function point, you have standard function point tables. How do function point tables look like? In function point, what we do is we try to we have to define our from our statement of work or the problem statement. We have to define how many external inputs are there, how many external outputs are there, how many queries are there, how many logical internal files will be there, and how many external interface files. 5 types of user types we have to identify. For these 5 types, how many are there? We have to determine. And for each one, suppose I have 5 like this, I have to say out of these 5, how many are low, how many are average, and how many are high. That means the complexity of each external input I have to express in low, average, and high. And having done it, suppose I find there are 2 low and 2 average and 1 high, then what I have to do? I have to use weight multipliers. How weight multipliers? That means if it is low, I will multiply it by 3. If it is average, I will multiply by 4. If it is high, it is multiplied by 4. This is a standard table. It's given in the FPIUG. If you go to a book, the website, they will give you this. So this is a standard table. Similarly, you have to determine what is this. So if you have 7 here, again you will describe it as low complexity, average complexity, and high complexity. Again, you have to use some criteria for it. So maybe number of records, number of pages, number of fields, and things like that. Number of options. So whether it has only list or it has summary. So based on that, you will determine whether it's low, average, and high. Then you have to count it. And after having counted, so suppose this is 7, you may get 3 out of this, and you may get 4 out of it, and you may not get anything here. So what you will do, you will multiply again this with this, this with this, this with this. Then you will get this, what is known as sigma of number and weight. So this is basically your function point count. So here you will get something, 2 into 3, 6, 2 into 4, 8, 1 into 4. So 5 plus 8 plus 6, 11 plus 8. So you will get 19. Similarly, you will calculate here 3 into 4, 12, 4 into 5, 20. So 12 into 20. So it is 32. Like that you have to do for all the 5. Having done this, now we will see. So now for our problem, we have to apply this, we have to apply this FP table and see how it is. So this is just an illustration I was telling you. So this is the same problem. We are continuing. So now we have to look into this problem description. Where is my cursor? Here. You have to go to the problem description and determine all these things. Your customer details. So you can see that for the external input, you will have to external input. It will come from outside. So from the user. So customer details will come. Customer requirement, how much they will need, it will come. Of which item, how much they will. So that is the item wise requirement. Then the goods, what kind of goods are there, some payment details. So these are all the inputs that will come. Similarly, you can count the number of outputs. So outputs, you can say that I will need a customer report. Some order report will be required. What are the pending orders or outstanding orders? Which are the already delivered orders? or how it was, how many days they were required. So you will have a set of order reports, you will have a set of stock details reports about the items, then billing reports. The bill has to be actually printed. And similarly, you can also look at the credit rating, how well your customers are, whether they are paying on time or not. Then queries can be there about customer, about order, about stock status. So at a very high level, at a user level, we are defining it. We are not defining it at a implementation level or at a design level, but we are defining at a user level from the way user sees it. And similarly, the internal logical file, that means those things that we will want to store. So customer information about goods, orders, some transactions about the goods. So all these things we will like to keep. So at least 4 ILF will be there, internal logical files. Then we come to external interface files. Now, as you can see from this description, we don't see any external, it is not interfacing with any external system. So we will not consider this. So we will say there is no external interface. So we will have our count will be 4, 4, 3, 4 and 0 here. And since we don't have, I am trying to keep the problem very simple. Since we don't have enough information in this small problem, we will consider the average. We will not go for low and high. We will consider that every input type is average, every output type is average, every query is average, every ILF is also average. So we will take the multipliers for the average and then determine the function points. So this sum is called the, so when we sum it up, it will come to 88. So this is called as the UFP, or the unadjusted function points. From the unadjusted function points, we will get the adjusted function point, which is the final output of the size, by multiplying what is known as a technical factor. So now this technical factor is defined like this: 0.65 plus 0.1 multiplied by degree of influence. And what is degree of influence? Degree of influence is what we were discussing, the environment, the kind of skills you have. So there will be 14 in the function point method. There are 14 such degrees of influence, which we will have to assess on a value of 0 to 5. If it is very low, we will give it 0 or 1. If it is high, we will give it 5. Based on that, we will give based on the severity of the impact of that particular driver, influencing factor, we will take that. And that influential factor, we will sum it up for all the 14 values of the influential factors. Then we will get the DI. Now this DI has to be put here, multiplied by 0.01, then added with 0.65 to get the this technical factor. And this technical factor will be multiplied by the unadjusted function point that we have derived by this method, and we will get the adjusted function point. Now, since we do not have any much information here, we can assume for simplicity that our TCF is equal to 1. If our TCF is equal to 1, if we take this as 1, then AFP becomes equal to UFP. So you can say my AFP is equal to 88. In other words, your size in terms of function point is 88, or this particular problem is 88 function points. Now let's look at a third problem. I hope it is very interesting to you, because we are trying to see, instead of just going into the estimation methods, we are trying to see how we can really solve problems. So here we have a graphics software problem. A graphics software we have to develop. And the software will execute on a workstation. And it has interfacing with mouse, digitizer, high resolution color display, and a laser printer. We have to estimate the project effort, cost, and time using LOC method. So the method has been given to us. And also some of the past data is given to us. Productivity is 600 lines of code per over person months. That means in 1 person months, one person works for 1 month can produce 600 lines of code. And the manpower rate is 9,000 rupees per month. Now what we see that we can, from the problem distribution, from problem statement, we see that the LOC we have already decomposed into these 6 components, because if you study this, you will understand that you need a user interface, you need 2D geometry, you need graphics display, you need database interactions, you need an analyzer module to see what kind of geometry it will be, and you also need some device controls. So at least these 6 it will be there. Now for each one we have to do the LOC. So what we will do, we will take the problem and go to see some of the past projects, or we will consult the expert. Let us say we have already determined the components to be like this based on some of this. So these are assumptions we are taking for this particular problem because we do not have enough data. You can put your, if you don't have enough data in your problem, then you can put your own assumptions. That is very fair and correct. So you take this, I have taken some assumptions, and for this it will give us a total size of 33,200 LOC. I have not converted it into KLOC. If I convert it into KLOC, it will be 33.2. Now using the given productivity and rate and the cost of client, what you will do? Rupees 15. How we got this rupees 15? What is this rupees 15? We calculated the rate, the cost of per line of code. Depending on the productivity and the rate given to us, we determine the cost of line. By we took 9,000. 9,000 is the cost, and 600 is the per person months how many LOC can be written. So if 9,000 rupees, that means for 600 LOC it costs us 9,000 rupees. So therefore one line of code will cost us 9,000 divided by 600, which is rupees 15. So we can derive the project cost by multiplying the size 33,200 LOC by rupees 15, which we have derived as the cost per line of code. So you get the cost. And similarly, you can get the approximate effort by again taking the cost. You have derived the cost and you can divide it by the cost per month. So if you divide the cost by cost per month, what you get is month. So you get a 55.34% months. This is what is the effort. So what we are asked to determine the estimate. So we have estimated the cost and we have estimated the person months. Otherwise also, alternatively, you can also take the 33,200 is your lines of code, and 600 lines of code can be coded. Lines can be coded in 1 month. So if you divide this by this, the same answer you will get 54.34% months. So this is another way questions can be posed to you and how you can solve it. Now we come to some of the other subsidiary plans, and we quickly go through all those things because estimation we have seen, the size and estimation. We have seen some कुछ झलक तो मिल गया आप लोगों को, but now we will go into the other ones because those are also part of the project planning. So what is the organization? How we will organize? So there are 4 different ways you can organize. One is the closed paradigm. You have to see where it will fit. If you know the benefits and the difficulties, then you will know in your particular project team which of these. There are 4 different ways: closed, random, open and synchronous. So in the closed paradigm, the structure of the team is like a traditional hierarchical authority. Somebody will have the hierarchy, authority, and everybody will obey. So this is normally called the chief programmer organization in software engineering. And this person has the full control. So that is why it is called a closed paradigm. What is the advantage? The control is very high. That is the advantage. But what is the disadvantage? There is no chance of being innovative. So these people are only obeying. They are not allowed to think. So innovativeness doesn't come. So this is good for small projects or for maintenance teams. Then comes the random paradigm. It is just the opposite of the closed paradigm, where you have a structure which is very loosely structured. It is kind of a distributed architecture. team organization. It depends on individual initiative of the team members. Leadership is distributed like a network, and but then you will have a communication overload. Why you will have a communication overload? Because everybody talks to the other person. They are all connected. So everybody talks. So the communication, it takes a lot of time of the project, and so you have a lot of loss. And it struggles when orderly performance and high productivity is required. So when you have something which has to be done in a hurry, then nobody knows who is going to do. So the roles and responsibilities are not well defined here. And there is no single person to give instructions. So then productivity suffers. So it is not suitable for large software development. Where it is suitable, suppose you are doing research or you are doing some experimentation, you are doing some prototyping, or if you are doing pair programming in the way of XP, self-organizing style, small little bit of work you are doing, refactoring kind of work, then you can use this random paradigm. Next we come to the open paradigm, which is a mix of the previous two. It is a mixed organization. Here you have something that is like the closed paradigm and something which is like the random paradigm. So what you have the closed one at the bottom. At the bottom it is closed, but at the top it is random. So here the people interact, but at the bottom level they don't interact. They take instructions. So all the innovative discussions and everything comes here, ideas. But here it is work, instructions. So you get both advantage of both. So most large software projects, they will use this organization. They will have some hierarchy of project managers on the top, then there will be team leaders, then there will be senior engineer, then there will be junior engineer, like an inverted tree, like what I have drawn here. Then you have a synchronous paradigm. Why a synchronous paradigm is required? Because sometimes you have compartmentalization of the business problem. So we have divided the business problem into different compartments, different areas, and what you are doing, you have created sub-teams for each one. So you are using something known as your agile method, and you have your increments, and each increment is going parallelly by using sub-teams, or maybe slightly deferred. Either they are going parallelly, this is time domain, or they are going slightly deferred. So when you have so many increments, at some point of time you need to synchronize. When this one goes to the delivery and this one goes to the delivery, somewhere you have to synchronize. So that synchronization, because they are independent sub-teams, there is nobody. So you need somebody, a manager or someone who will be the point of synchronization. So that is why you call it synchronization paradigm. So what you will answer? You will answer that there are 4 types of project organization, and then you can give the benefits and the situation and difficulties, and you can write situations where it is applicable. How is the team coordination and communication? I will try to skip this because we will lose time. But basically there are formal, impersonal, interpersonal, then there are informal, and then there are electronics communication, and there are some networking with outside people. So because there could be some, we talked of team members not being co-located but at external people. So how communication plan is a very important plan, but we will not spend too much time on this. Now we'll come to a very important thing which is called metrics and measurements, because metrics help in managing projects, because this is part of the monitoring, how the project will be monitored. So what is the difference? First we will see what is the difference, then we will see how it is helping. So what is measurements? Measurements are raw data collected about various activities and products by the project team. So as the project is going on, a different set of resources are doing different tasks and different work products are being produced. You keep collecting the data about it, information about it. And these are measurements. But if you take the raw data and you convert it into specific metrics by using some formula or by analyzing it, then what you get are indicators about the project, about the way the project is going on, the trends, the way it is doing, the health, the conditions. So that is called as a metric. So this is called as a metric, and the data that you measure is called as a measurement. So unless you do the measurements, you cannot get the metrics. So measurements or collection of data is required to produce metrics. And what is the use of the metrics? Metrics are used, data will not give you the indicator. The data will not tell you whether the process is going correctly or not, but you have to convert it into metrics. Metrics are the indicators about the health of the project. So metrics are tools used by the project manager for assessing quality of the product to be delivered. Metrics provide insight for process, monitoring and control, and also affecting any improvement of the process. Metrics also provide important indicators for different project level quality parameters. So these are the use, why you need to have projects and why you need to plan for the metrics in your project. Differentiate between process and project metrics. So we said different types of metrics. So what is the process metrics and what is the project metrics? This question can be posed in different ways. I have just put it this way. So what is process metrics? They are indicators of the health of the process quality. They are computed for each project and they are collected across different projects for the carried out over a long period of time. So each project is creating their process metrics and they are contributing, which is stored in the organization's project database. So when we are talking of past projects, this is basically the project database, the history database. So all the project process metrics are being kept there. And why it is being used? Because they provide you information about project process quality. The objective is to provide a set of process indicators that provide the process quality level leading to long-term software process improvement. Even if you have not done it over that particular project, but for later projects, you can do the process improvement. So you collect metrics and you keep it in your database. Then you have project metrics. Project metrics enables a software project manager to assess the status of an ongoing project. So here we are contributing to the organization and here we are contributing to the particular project on hand. There are tactical decisions we have to take. So we have to assess the status of the ongoing project, track the potential risks, uncover problem areas, and adjust the workflow, task efficiently, check how well the software team is able to control the quality. This is also another thing because the product is coming out of the project. So all the product quality metrics come under the project metrics. So overall, how the project is doing, what actions the project manager has to take get decided by the project metrics. How process metrics help in process improvement? So what you have to do, you have to write that you have to improve the process performance. First, we have to measure the specific attributes of the process outcome. So the process outcomes are measured and certain metrics are derived. What are those kind of metrics? I have noted down some of the metrics. Errors detected before release of the software. It normally called as a defect density. There is a formula how to determine. Similarly, defects reported by end user, that means after it is delivered, so they are called residual defects. Work products delivered, you can determine it by productivity, LOC or FP over person months, or you can do it in some other method. Then manpower spent for each process, how many person days or months is spent for each effort. Calendar time used, schedule conformance, that means number of late deliveries divided by total number of deliveries, or days delay divided by days planned. So these are some of the ways schedule conformance or compliance can be checked. And other process measures, the number of measures the project manager has to plan based on the characteristics of the project. So what we are looking here, how the process metrics help in process improvement. So first of all, we have to define these kind of project metrics for the project and measure them. Then we can also go for some of the software engineering tasks. We can go to the software engineering tasks and then determine for each task analysis, design, what was the effort and time spent. Here we are doing it based on the resource or the work product. Here we are doing it based on the type of software engineering tasks. And these metrics will help detecting areas for applying process improvement. So we will know where we are below the target. So always you have a organizational benchmark. You have an organizational benchmark. Where am I here? You have a 1 minute. You have a benchmark because we said process metrics are measured over the all projects. So the process database, the benchmark will be produced. So based on, with respect to this benchmark, whether you are at a lower level or you are at a higher level. If you are at a lower level, that means you are below the target, below your own target. Target is done based on the benchmark. Then that area needs process improvement. That means your process is not good enough. You have to improve it. And also measure effectiveness of the, and once you have created some process improvement, you need to know whatever action you have taken, whether it is effective or not. So the effectiveness also you can measure by using the process metrics. Now you are asked a very simple question. You are the PM. Which are the process quality metrics that will always produce? So these are how it will help you. And to help this, what are the normal minimum defects, the minimum metrics that you will define? For what reason? For process metrics. How many process metrics you will define? So as we have seen, defect removal efficiency. Defect removal efficiency is measured by E by E plus D, where E is the number of defect removed before delivery and D is the total error. That means what you got before and after delivery. Then you have the defect density, that is the defect injected during the development, number of defects detected divided by the size or by the size in FP. So how many defects have been injected during the development time? This is how many defects have been removed. This is how many defects have been injected. So that is, this is the defect density. This is the removal efficiency. How much you have removed. If you have detected, you can remove it. So how many you did? This is based on the detection. This is based on the injection. Again, it will depend on this. There's a relation between these two. As you can see, you can obviously guess it. Then you have productivity metrics, which is the ratio of the software size and the effort spent. LOC person hours or LOC person FP person months, classes. These are object oriented. Then you have classes. You don't have LOC. So you can say these many classes person hours. What productivity metrics is to be measured for each activity, resource person or averaged over the complete. So minimum these three are the minimum process metrics which you need to define in each project. Apart from it, you can define more. What is the use of project metrics? Now we have completed process metrics. So what is project metrics? As a PM, what project metrics and measurements will you plan? Because metrics is, all these metrics are part of the project planning. So project metrics are used by project manager to take tactical decisions about the project. Minimize the development schedule. We always have to see that that schedule is maintained or minimized. And we have to mitigate all the potential problems, and we have to avoid delays. We have to take care of risks. We have to also do product quality assessment. So because we have to do the process quality improvement, so and not just like we have to do the process improvement, we have to also do the technical approach. We have to improve the technical approach so that our quality of our product will be better. So these two things. So what is the use of the project metrics? This is the answer to it. Minimize the development schedule, mitigate potential problems, risks, assess product quality, and improve the quality of the product. And what are the project metrics? Just like we saw the process metrics, what are the project metrics we will plan for? Effort used on activities, productivity achieved, resource utilization, schedule and cost compliance, and certain characteristics of the product quality. Because product quality is also important project metrics. So here what we do, we make measurements of the inputs. For computing these kind of metrics, we will have to take the inputs, the measurement of resources, people's tools required to do the work, outputs, how much has been produced, and results. Results means basically the deliverable, how effective they are. And we can take direct measures like lines of code or function point or hours or things like that. And we can normalize it. Or we can take some indirect measures. That means they are some formula of something we have measured. So we can create, especially for the product quality, all the product quality characteristics are taken and a type of formula is arrived to determine it. So what are the kind of product quality? It can include the functionality that has been delivered. It can deal the complexity. It can also see the efficiency, the reliability, that means it's not failing, maintainability. So all the quality characteristics that we require the product to acquire, those things, when we want to measure it, we have to go for an indirect measure. Now you can be asked a question, because product quality is so important, what are the name of some of the metrics for software product quality that can be planned? Normally, what is done? So some of the very important metrics, quality metrics, are correctness or accuracy measured by defects per LOC. So as you can see, we have seen this earlier as a project metrics. So the same project metrics is giving us a product quality also. Similarly, maintainability. Maintainability we did not discuss earlier. It is a characteristic of the product quality. So this is mean time to change. We can measure maintainability by mean time to change. How much time we are taking to respond to a change or to affect a change. Measures the time required to analyze and implement a change request. And that we have to measure over many changes and determine the mean of it. Then, of course, we have to do some kind of a normalization. Integrity or the security. This is measured in terms of probability of threat and security measures that will prevent the attacks. So how much, first we have to determine what is the probability of threat. Then we have to see how much of the security measures we have taken, and we have to calculate some kind of a derived metric that by using the security measures, how many of these threats have been able to prevent. So that is the integrity or the security measure. Then you have the usability. This is normally connected with the user interface design. How good the user interface design in terms of usability characteristics. So usability characteristics we have discussed under the UI design. So those characteristics now we have to measure. Again, they are indirect measures. So that is called usability quality of a product. Other software product quality metrics, understandability, completeness, concise, consistency, depending on whether they are required or not, we will do. But normally for all online interactive, we will have usability. For mostly we will have security, integrity, we will have correctness and things like that. Now we'll quickly look into some of the these things. We have run out of the time. We have exceeded the time. So there are size-oriented metrics. Let's look at the meaning of the size-oriented metrics. The project metrics that are measured on LOC. So everything is on LOC. Then you have function-oriented metrics, which are measured on function point. Function point is used as the measure of size. So or the complexity, and everything whatever we did there as size or k-log, now we are doing it based on the function point, errors per failures per function point, defects per function point, cost per function point. So we call it function oriented metrics. So whenever you are asked to give examples, you have to look into this and see it. This is how you can convert the function point to LOC, average LOC per function point. These are standard tables that are available in the internet. Now you have, suppose for specific projects, if you have object oriented metrics, then some of the previous LOC and FP metrics may not be very suitable. So then you can go to OO specific metrics related to size and functionality. So you can have scenario scripts, then you can have use cases, you can have key classes, support classes, average number of support classes per key class, number of packages, components or subsystems. So these are object oriented metrics for size and complexity. Similarly, if you are doing a web engineering project, then you will look for web oriented metrics because other things will not help. So there you will look for web design, because you are doing web design, and just like there you are doing OOAD, here you are doing web design. So static web pages, dynamic web pages, internal page links, persistent data objects, external system interface, static content object, dynamic content objects. So all these things, executable functions. So these kind of things become important, and again they depend on they are related to the size of the thing, or they are related to the functionality. And this is, I think, my last slide. Illustrate how metrics can be integrated within the project's process improvement. We are always talking of process improvement. So what you are doing, you have software process, you have software project, you have product. So the project metrics were defined over this, the project, what you are doing, and the product qualities. And your process metrics were defined over this. So you have collected data, then you have taken the measurements, you are computing the metrics are coming, you are evaluating the metrics, that means you are analyzing the metrics, some indicators are coming, and you are doing the monitoring. This is a continuous process, it keeps doing, it's in a cycle. So each time you are doing a process improvement, or you are doing an adjustment, or you are doing a process improvement, so you are monitoring all these indicators, and you are resetting your goal, because the moment you do a process improvement, you have to set a higher goal. Or if you are below it, then you have to make the adjustment and you have to approach the goal. So this is how. So what you do in your project, you have in your project planning, you have to put this into your project planning, in your process, in such a way that it will become automatic. Process measurement and metrics needs to be part of the software process activities to provide advantage of control of improvement. So this whole thing will become part of your process, software process. Coming to the end, we have discussed basics on project management, planning, looked into the SPMP, activities, contents, and the output. Then we have seen the estimation forms, and we did some problem solving. We discussed how resources of the team can be organized, the team organizations, what is the advantage, disadvantage, where you will apply which organization. We also discussed the planning of metrics, very detailed we have discussed this. And then finally we have gone to the product quality metrics, and we have also discussed what is object oriented metrics, web engineering metrics, and we have seen how it can be the metrics, the measurement and metrics and affecting your process and quality improvements, how they can become a part of the software process. So thank you all. This time I am not able to see the live chat. Okay, so I don't see much difficulties that you are having. If you like my class, it's good. And thank you all. In the future, I will. We have another 4 or 5 classes. So I will be dealing with other aspects of the project management, which will also be very interesting. And you will have a lot of questions on this in your academic classes, in your academic examinations, also in your interviews for your job. And it's a very practical thing because this is what you're going to utilize the most when you become software engineers, because most of you will become software engineers, and when you go to your job you will find that so many things that you learned in your class you didn't use, but what you learned in your software engineering, software project management, you are actually using it. So I'm ending here because we have almost run half an hour extra. Thank you all and good night.